Right. So here, um, so let's go with doubly linked list. Now, I explained the previously. I explained the structure or the fundamental concept of doubly linked list. So doubly linked list, we have links, we have connection to the next node as well as to the previous node, right? So here, if you see the structure, so usually the last node's next node is usually none. Similarly, the first node's previous node is none. First node's previous node. First node does not have a previous node. Already node a previous node. So that's why it is none. Right? Simple as that. First node does not have a previous node. So that's why it is none. The last node does not have a next node. So that's why it is none. So the idea is very simple. Okay? Right. And the other thing is in this example, so actually this is double-ended doubly linked list because it has last, right? It has a connection to the last as well. But usually when we name this structure, we don't just say double-ended doubly linked list, right? Usually in a doubly linked list, right, we consider the last one as well. Last doubly linked list generally are double-ended as well. So I mentioned like double-ended, doubly, it is two different things, but when it comes to doubly linked list, we combine those two, but we don't mention it usually on the topic. Right? Linked list එක double-ended, doubly එකක්. හැබැයි අපි දෙකම දාන්නේ නැහැ. Doubly linked list වල සාමාන්‍යයෙන් double-ended කියන එකක් තියෙනවා කියලා අපි සලකනවා. If you cannot access the last item, cannot access the last item, last node, then traversing backward does not have much use. Right? अंतिम एक access करना पड़ना पिटिवस रहने के समारोह लोगों तेरुमक नहीं हुए. That's why in a doubly linked list we add double-ended feature as well. Right? Right, so let's see the implementation. We have fundamental change in the no. So we have to add additional variable for previous. Right. Right. So I added the previous variable here, and then to getters and setters, get previous and set previous. Right. Then is dot set previous with none. At the beginning, both are none. So now node is okay. I'm going to change the name of this one to doubly. Doubly linked list. Doubly linked list. We have first class, that's fine. Right, so we have created doubly linked list. Doubly linked list with the no. But we have to change the insert, maybe delete. So let's see how it goes. Right. We added the previous. And then traversal. Traversal means go through the link. So or display, right? It will create a display list. So this method. Display all items in the link list. Right? In our previous implementation, so we created display forward, actually from front to back, right? So in our list, right? So we display from front to back. And we can display the other way around, from back to front. Start with this one and then display the last one, previous one to the last one, and so to the first. We can have two display methods. There are two display methods. Display forward, which is similar to the display method of the normal linked list. Display backward is the new addition which travels backward and display nodes. Right. So let's rename display forward. Display all items in the linked list from front to back. Right. Similarly, so we can have another method. Display back. When we display backward, we have to start with the last. So we used indices, right? So in this case, let's remove this index. Yes, okay, yeah. Let's remove the index. Current current is assigned with current dot get previous. Previous. This is public. It has to be public. That's it. Okay, right. Display backwards. In previous case, current assigned with current dot get next, current dot next. So here, current is assigned with current dot get previous until current becomes null. You to make a previous null and then make a next take up null. Right, we start from here until it becomes null, until it hits here. Making a but display back. Start with the last, current start with the last, and then current assigned with current to previous. See, that's the only difference. Display forward, backward. Here and here. The only difference here is it's last and then get current to previous. Right? Then when it comes to doubly linked list, so insertion. We can have three types of insertion methods. Insert first. Insert as the first element. Insert last. Insert as the last. Or we can insert any specific place, right? As we did in this example, right? Here. So if you remember, right? So we inserted in a specific place, right? So we can do that. If we take doubly linked list, insert can be three types. Insert number one, insert as the first. Okay. Insert as the last. Insert, the third one is insert at specific location, specific position. Insert first, insert last, insert at specific position. It has named as insert after. Insert after means insert after a specific value. So from these three, like implementation can be done for all, but insert first example has been given. Okay. So let's see what happened when we insert first. Right. So let's see. Insert first. This. So let's see what's happening. So new item is here. So we have to insert it as the new item, the first item. So here, මෙතෙන්ට මැදට රිංගවන්න ඕන. So these are the steps that we have to do. We have to change the first pointing to the new item. First has to be pointed at the new item. And new items next has to be pointed. New items, sorry. New items next has to be pointed at previous first. So this one, this one. And then previous next items, previous. Has to be pointing at the new item. New items previous should be pointing at now. Right. So these connections should be made. That's all. So then the new item would be here. See, newly inserted item here. Right. New item. Right. Then we have to check whether in the case of the list is empty. If list is empty, it is a special case. Right. If list is empty, so then we have this kind of situation. List is empty. First, the last. Looking at now. Right. So then, if we create a new item, right? So that the value would be added here, and then next and the previous. So the next should be assigned with null. The previous should be assigned with null. And the first has to be assigned with the new item. The last has to be assigned with last has to be assigned with Yeah, let's see. Let's see. If empty, the last node is assigned with new node. Right? If empty. Otherwise, if it is not empty, the first item's previous is assigned with new. So this is okay. Else has to be empty. That's the difference. Else, what we have to do is, right, the last would be assigned. This case, last would be assigned with new. In this case, otherwise, if it is not the first, right, else, right, first items, like old first items, old first. Yeah, අලුත් එක දාන්න කලින් first එක. First dot previous would be dot set previous. Yeah, right. Right. New items dot set next would be first. Right. Those are there. New items next would be first. First would be assigned as the new node. Set first, new item. New item. Okay, so this is the insert first. This is the only difference. This is the only difference. Doubly linked list deletion. So insertion, as I told you, there are several other. Insert first, insert last, insert after. So here we have discussed only insert first. Similarly, we can implement insert last as well. Yeah. So here, insert last. So when it becomes like insert last, last. Something like this. Right. So if you want to insert a new node at the last node, so what you have to do is current last node next has to be assigned with this new node. Current last, previous is fine. Then new nodes previous has to be assigned with this one. Last. And then last has to be assigned with this one. New node. කලින් last එකේ next එකට new node එක set කරා new node එකේ previous එකට last කලින් last එක set කරා ඊට පස්සේ last කියන එකට assign කරා new node. It's something. Right, so then if 70 first would be new item, right? Else last would be set next new item and then new items. Dot set previous. Be last. Let's set this here. Is the difference. Right. So insert last. Insert after. So I'm not going to create that method, but you can get your own method if you want. Right. Okay, so let's go for deletion. Right. So any questions? Any questions up to now? I mean, there should be many questions. So if there are no questions, that means you haven't understood anything. You are so you have lost, or so you are lost, and then you didn't get anything, right? So that's my interpretation of your so no questions situation. So Arafat, did you understand what we are doing here? Or do you have any questions? Arafat, are you there? Asiru Madhushan. So did you get this? Do you have any questions? Ashiru Madhushan. So yes means do you have questions, or did you understand? So did you get the idea? Yeah, so it is hard, of course. I mean, this is not easy. If it is easy, uh, these things wouldn't be teaching at university level. So it would be teaching at O levels, so in O levels, or A levels, so maybe it would be teaching to elementary kids. So that's why these are taught for so the students who are qualified. So you are qualified students, right? So that's why we are teaching these things to qualified students, right? So it is hard. I mean, it's not easy. Like these, the programs would be, yeah, I know it would be kind of confusing sometimes, but still, if you understand the basic idea, right? Like, so in the insertion, what are the things, what are the steps that we are doing here? If you understand those steps, so then that's fine, right? So that's what you, so mainly if you understand this, then we can easily go to the next step, implementation. So Ashiru, so what are the questions do you have on this insertion? Do you have any questions at the moment? Okay. Right. So let's go to the deletion. So that's the last thing that we are going to discuss. Again, deletion can be similar to the insertion. There are also 3 deletion routines. We can delete the first, or we can delete the last, or we can delete a specific item. Right? So deletion, right? So we can delete the first, or we can delete the last, or we can delete a specific item. First, we have to search what to be deleted. Can අපි දෙනවා මේ value එක, suppose the value of this one is 50. Value 50 should be deleted, right? So then first we have to search where it is, right? Okay, so here it is, we found that, and then we delete it. We delete this. After deletion, this one's next has to be this one, and this one's previous has to be this one, and then that's it. So deletion. So again, there are 3: delete first, delete last, delete. So let's implement some of them. Delete first the first items of the linked list. Let's see what are the changes that we have to do if we delete the first item, right? First to be this one, the last this one, and then we have next and previous. This is previous will be none. Right. So if we delete the first item, basically what we do here is we use variable temp. This temp variable is assigned with the first. Then first is assigned with first dot next. First dot next would be this one. So the first would be assigned with first dot next. This one. Right? Then after that, actually, we can return this. We can return this temp. Temp can be returned. However, additionally, we may have to do something. Right? Like, okay, now if you remove that, temps next can be assigned to null. Temps next can be assigned to null. And then the first previous could be assigned to null. Right. Then we don't have this connection. We don't have this connection. The connection has been broken. Now this is isolated. The temp is now isolated. So I'm deleting it. Right. Now this is null. See? Temp. So let's come to this one later. First is assigned with first dot next. First dot get next. Because we have getters and setters, that's why we use this method. First is assigned with first next. So the temp dot set next is assigned with null. Temp के next එකට assign කරනවා null එක. Additionally, so we should have something like this. Anywhere, right? First dot set previous is assigned with first can aluth first එකේ previous එක වෙනවට null එක assign. Right? That's all. So if there's only one element, if there's only one item, then right, there's only one item, right? And the last would be this one, right? Right. So we are going to delete this. Next and previous both are null. So if we delete this, so last would be null. That's all. Last could be assigned with null. Right. First would be assigned with first dot next. First dot next again it is null. First එකේ next එක කොහොමත් null නේ ඒකින්ද ඒකත් null. Then we can delete this. If there's only one. Right. Okay. So we check that. So otherwise, these are the steps. Delete first. So did we create delete last? Yeah. So let's create delete last. Delete last. Delete the last item. So let's see what are the things that we have to do. Okay. We have the first and then we have the last. First, and then we have right. So this is the one that has to be deleted. It has to be the last. Last is assigned with the 10. Okay. So let's deal with this one. Where let's check whether we need this like later on. Huh? Right. So then let's see the steps. Right. So we have temp. Temp is assigned with the last. The last වල තියෙන variable එකේ තියෙන value එකම copy කරනවා temp එකට. ඒතකොට ඒ තියෙන්නේ මේකේ address එකමයි මේක. So temp is now pointing at this one. Then so temps previous. No. Yeah. Temps previous. So that means this one. Temps previous. Right. Temps previous next should be assigned with null. temp එකේ previous. Temp's previous means this one. That one's next. This point has to be assigned with none. That means this would pointing at our null can come with none and that. So I'll put null here. It is pointing at none. So now it is not pointing at this one anymore. Right? Then the last, right, should be assigned with this. We can change the steps as well, right? So instead of this one, right? So before that, right? Rona එක පොඩ්ඩක් change කරන්න පුළුවන්, right? මෙන්න මෙහෙමනේ කලින් තිබ්බේ. So temp is assigned with the last, right? Then we can do something. Last can be assigned with temp dot previous. temp එකේ previous එක يعني temp එක කියලා කියන්නේ මේක, ඒකේ previous එක කියලා කියන්නේ මේකේ address එක assign කරනවා last. So that means last is now pointing at this one. This is the last. Then this has assigned to last. කියන්නේ last කියලා කියන්නේ then temp dot previous. Can change to last. Last dot next is assigned with none. Now last dot next can be assigned with none. Then temp dot previous. Temp dot previous. That means temp is this one. It is previous. This one can be assigned with temp dot previous can be assigned with none. මෙයාව assign කරන්න පුළුවන් null එකට. Now temp can be returned, no problem. That's how we delete the last. Delete last. Last can be set. No, last can be assigned with directly. Can be assigned with last dot get previous. Last එකේ previous එක අරගෙන ඒක assign කරනවා last. දැනට තියෙන last එකේ කලින් එකට last කියන එකට assign කරනවා අලුතෙන් last එක. Right? So then the next step. So this has been done. Okay, so this could be last dot previous වෙන්නත් පුළුවන්. නැත්නම් temp dot previous කිව්වත් හරි. It is also fine. Temp dot previous or last dot previous. මේ මෙතෙන්ට temp කියලා දැම්මත් අවුලක් නැහැ. මොකද temp කියන එකට last එක assign කරලා තියෙන්නේ. Both temp and last are the same at this point. Right? So whatever, that's fine. And then last dot next is assigned with none. New last. Now last has been changed. Last dot set next. Right? We set the null. This one okay, the second one is okay. Last one would be temp dot previous is assigned with none. Temp dot set previous is assigned with none. Right. So we can check whether this last is if there are only one item, and then if it is empty, we can do some checking, right? So I'm not going to do all those things. You can add them here. These are the basic steps. If there's one element, right, so let's see that as well. If there's only one element, next previous would be again none. If there's only one item, so after deletion, so we have to change the first to null, last to null. Last to null would be sorry. So this is there. Right. So then if there's one item, this has to be right. Else, so we can do this. Okay. So that's delete last, right? Then delete a specific item. Delete a specific item. So again, in this case, right? So we have to find a specific item. And we delete that like this. So we can use current dot previous, current dot next. Current is the variable that we are using in searching. Search කරන්න පාවිච්චි කරන variable එක current. අන්න ඒ current කියන එක පාවිච්චි කරලා අපිට පුළුවන් ඒක delete කරන්න current dot previous කියලා කියන්නේ මෙන්න මේක. current එකේ previous එක මේක, current එකේ next එක මේක. ඒ දෙක connect කරනවා. So we can connect them together to remove a specific item that we want to delete like this. So the idea here is, so this is the current which has to be deleted. Right? I mean, search करने एक अमतक करूँ जाने search करने का same as the searching is same as the previous methods in previous searching methods. The only difference is how it is deleted. here, if you want to remove this, this highlighted one has to be removed from this list. Then the currents previous, that means this one's next should be assigned with current next. That means this. I mean, it seems a little bit complicated, but the idea is very simple, right? The idea is very simple. Right, okay, so let's go with addresses, right? Like it will be easier to understand with addresses. Suppose, so I'm putting like just simple numbers as addresses, right? The address of this, the first node would be 10. The address of the second would be 20. The address of the third would be 30. Right? Okay, so the middle one has to be, okay. So let me put, so we have the value here, and then next and previous. Next and previous. We have next and previous, right? And then we have data here. So we have data here and next and previous. Right. So we have variable first, right? First. Variable first would be value 10. Variable last would be the value 30. Last kena variable එකේ තියෙන්නේ අන්තිම එකේ address. First kena variable එකේ තියෙන්නේ පළවෙනි එකේ address. So the next of the first element would be the address of the second. First one's previous would be none. The next of the second item would be the address of the next item, third item. The variable previous of the second item would be the address of the previous. That means 10. The address of the next item of the third one would be none. And then the previous of the last item would be the address of this event. Right. So this is how it is, right? With memory addresses. Actually, these addresses are hexadecimal numbers, but I'm using just simple numbers just to make it easier. Okay. Right. So what I want to delete this one. I want to delete this one from this list, right? what I do is, what I have to do is, I have to create a connection between the first item and the third item, right? Link those two. So how to link that? In this case, so we use variables, current. This is where we are going to delete. Currents previous means address 10. That means this. So the current dot previous. This is current dot previous. කියලා කිව්වහම අඳුන්වන්නේ අපි මෙන්න මේක. Current dot next means this one. Dot next. Current dot next කියන්නේ එයාගේ තියෙන address එක 30. ඒතර address 30 තියෙන මේ මේක තමයි. Okay. Right. So what I'm going to do here is current dot previous dot next. If I put another dot and next, current dot previous means this one, it is next. This variable. So we can, if I assign that with this value instead of 20, if I assign that with 30, right? So the 30 means current dot next. Current එකේ next එක තමයි 30. ඒක 30 කියලා අපිට එහෙම කෙලින්ම address එක ගන්න බෑනේ. ඒ වෙනුවට අපි මෙතන assign කරොත් instead of using value 30, current dot next. Current dot current dot next means current is this one, it is next, it is next. This value would be copied to this one. Current dot next value would be copied to current dot previous dot next. Current dot previous is this one and next is this one. So that value would be copied here. Instead of 20, 30 would be copied there. So now you can see this is pointing not to this one but to this one, because address of this one 30. Again, මෙන්න මේකේ next එක point කරන්නේ මෙන්න මේකට තමයි. So similarly, so we have to do something else. Current dot next is this one. So it is previous, is 20. 20 means this one. We have to change it to not 20 but to 10 to bypass this middle one, right? The 10 means current dot previous. So what we have to do is what we do here. Current dot previous dot next is assigned with current dot next. Current dot next dot, it is previous. Previous is assigned with current dot previous. Dot previous. So if we do these two steps, right? If we do these two steps, then, right? So in the second case, this one would be assigned with current dot previous. Current dot previous means 10. Now this one is pointing at this one, not this one. Make it but this one to the previous. Now this one is pointing at this one because of this line. This one is pointing at this one because of the second. Now we can easily remove. Current can be removed. See? Current is removed. See? We create these connections. Then currents previous and next can be assigned with none. Very easy. Right? So it has been given here. Right? So delete key first, we do searching. Right? So in a while loop until the key was found, until match is found. The while loop goes again and again. So after finding that, now current is where we have to delete. So if current is first item, the first is assigned with first dot next. Else, not the first, right? So then current dot previous dot next is assigned with current dot next. Current dot previous dot next is assigned with current dot next. Okay. So if current is last, last is assigned with current dot previous, else current dot next dot previous is assigned with current dot previous. अंतिम current කියන්නේ last එක නම් delete කරන්න ඕනේ මේ මෙන්න මේකයි කරන්න ඕනේ. එහෙම නැත්නම් තමයි මෙන්න current dot next dot previous is assigned with current dot previous. Then return. Delete any given value. Right. delete delete key, delete specific or whatever, right? You can name is delete any given node. Any node with a given value. Value can be given here. Key or value, whatever that is, right? So we can start with we can use variable with node type. It is assigned with first, and then we search for the value until key is not current dot data. Current dot get data. Current can be assigned with current dot get next. So current, so sample current get next. At any point, if current is null, if current goes up to the end, right? We have checked that as well. If current becomes null, so that means we have searched all the items and the search has gone up to the end, right? So that means we haven't found what we are searching for. Then just return null. That means if we haven't found the key in the linked list. Right. This is, so if we haven't, like if this has not happened, right? So then we will come to here. If we are here. That means the key has been found. ඒක හම්බුනේ නැත්තම් මෙතනින් කෙලින්ම රිටර්න් වෙනවා නල්ල. එහෙම නැත්තම් මේ while එක key එකට සමාන වුණොත් while එකෙන් ගැලවෙනවා. while එකෙන් ගැලවිලා මෙතෙන්ට එනවා. Right? So that means we have found. Right? If you have found, so then we are here. So then if current is current equals first. So we have searched for a key. So it is in the first element. Right. Equals the first. Then first is assigned with current dot next. First is assigned with current dot next. Else, all right. So here current dot next, we cannot get that as in our implementation. Get next. Current dot next kila kelima ganna bෑනේ. Get next. Else current dot previous dot next is assigned with current dot previous dot get previous dot get next or we can say set next. Right. Set next current dot get next. Right. So I have written the same in my implementation, right? Then if current is last, then last has to be assigned with current dot previous. If current is last, right? Current dot next. Current, sorry, last would be assigned with current dot previous. Yeah. So last would be assigned with current dot get previous. Else we do our second step here. Current dot get next set previous. Current dot get next dot set previous. the previous with the value current dot previous. Current dot get previous. Get. Okay. The same thing has been done. This one has been done in our implementation like this. Okay, right. This one has to be returned. Oh, current dot set next. We can add the null. Oh, current dot set previous. Be null. Right, so then we return the color. Right. So that's the delete. Delete any item of the linked list. Right. So that's the end of the long description of doubly linked list and basically the linked list. Right. So here, so if I summarize the things that we have done here, so we have created doubly double-ended linked list with these methods. So in there we have first, last, and then is empty. So insert first, delete last, delete key. Right, delete key or delete specific item, right? You can change the name as you wish. And then insert last and display forward, display backward, search or find, right? Get first. So these are just getters and setters. Get first. So we have implemented different types of method to access different perspectives of doubly linked list. So first we learn general linked list. And then double-ended linked list. Or double-ended linked list. Finally, we discussed them, right? So basically what you have to do is you have to understand the concept. So in any operation, what you do actually, what you do there. Right? Okay. So any questions? If you have any questions, this is the time. You can ask any questions. And the other thing is, so you have a homework, right? You have a homework. The assignment is there. Apart from that, so when you go through these operations, right? For example, I want you to identify the big core value of each of these operations. So each of these operations, for example, delete first. What is the big core value? What is the big core value of this operation? So likewise, all the operations here, I want you to check the big core value. So next week, so I'm going to ask that question. Okay. Right. So the other thing is, so now we have so next week, so we'll have another two or three lectures. So I'm going to have a quiz, right? So it is considered as your mid-semester examination, mid-exam or mid-quiz, right? So I will let you know the date. So next week, I want to have it on next week, but I can give you another week, right? Maybe, yeah. Okay, if you're okay, so we can have it on next week. So with this quiz, right, together with that, there would be Viva. Right. First, I will have a quiz, and then I will have a Viva. So in this case, I would ask up to general linked list. So that means I'm not going to ask very deep into the doubly linked list and all. But so if you have the idea of a general linked list, right? So then that's enough. So that means arrays, and then sorting, binary search, basically searching, and then stats and queues, and then linked list, general linked list. Those things would be asked. Right. Right. So any questions? Any questions from these things or any other things, the things that we have discussed today? And then the next two lectures. So today we discussed lecture 8 slides and lecture 9 and 10. These two set of slides are very simple, right? So there's no very complicated things. The lecture 9 would be basically on pseudocode, and the 10 would be recursion. So recursion, like you have some experience on that, right? So, so I will let you go through these slides later on. So the next main topics would be trees, right? Lecture 11 and 12. Those things would be mainly discussed within next 2 or 3 weeks, right? So I will think of lecture 9 and 10, whether I'm going to have a proper lecture or maybe I go with tutorial sessions. So those are not very difficult. Right, so that's how, that's the plan, right? So if you have any questions, you can ask. So I have taken additional time today, but if you don't understand these things, right? Like, I mean, if you're a little bit confused with these programs, don't worry, right? First, try to understand what's happening there, right? Then inserting what's happening there with those variables, how values are changing, how these arrows are changing. So those things should be understood. If you understand that, that's enough, actually, right? This process, what's happening, that process has to be understood. So this has to be understood by yeah, like, I mean, for this module, because it is data structure, you have to understand the data structure and then the algorithm, what is happening there, the steps. Writing the program is something secondary. It is necessary, but if you understand the process, it will be not. It will not be. It won't be very difficult, right? Okay, so that's all for today, right? So check the assignment, and then check the notes. All the notes are on the LMS, and then later on I'll upload the examination questions, previous examination questions, past papers, so you can have a look what kind of things that I expect from you, right? So the exam would be in another 2 months or so. So we have enough time, but so I will have a quiz and a viva, right? So you have to prepare for that. So the next week, next Wednesday would be preferred, but if it is difficult, so I can give you another week. In 2 weeks, we can have this. Let me know, huh? Right? Okay. If that's all.